Okay, so running brake level, is this simply if I have it in bidirectional mode, how much brake will it apply in order to change directions or change speed?
This is when you've got complementary PWM on. So complementary PWM, when you go from a high throttle level to a low throttle level, the motor will slow down actively. It'll brake, and running brake level is the amount of brake from those changes. So if you turn complementary PWM off altogether, the motor would freewheel. So this is how you'd drive an RC race car, for example. So it means you give it throttle. When you let go of the throttle, it slowly spins down until it stops. And that would be behavior with complementary PWM off. With it on, if you were to go from a high throttle to a low throttle, it's going to just immediately drop speed, brake hard, and regenerate a little bit of that power too while it's braking. So running brake level is how quickly it will slow down when the throttle is dropped.
Okay, so I'll move over to check marks. So yeah, so you explained complementary PWM is just if you have a throttle change, it will brake to that throttle range instead of just freewheeling, correct?
Yeah, so it activates both the top MOSFET and the lower MOSFET in alternating, basically alternating back and forth to provide PWM rather than just the top MOSFET only. So it means it's going through basically a driving, then braking, then driving, then braking phase 24,000 times per second. Where if you turn complementary PWM off, it just is just driving. And so it'll freewheel down to a stop.